Hi, I'm Z.
I'm Megan.
And I'm Maddie. And today we'll be going into depth of the physics, specifically behind the forces and dynamics aspect of doing an ollie.
We will be discussing forces, a unit we covered this year, and dynamics, a concept we have now been over but will indeed enlighten you briefly on an ollie. So, first, an ollie is a jump performed without the aid of a takeoff ramp executed by pushing the back foot down on the tail of the board, bringing the board off the ground.
Let's see what it looks like. Before a skater performs an ollie, there are three forces acting upon the skateboard. The weight of the rider, shown here with the two black arrows, the force of gravity on the board itself, shown here with a red arrow, and the force of the ground pushing up on the skateboard, shown here with two blue arrows. These three forces balance out to zero.
Now, let's slow it down and take a closer look of what it actually looks like of Z doing an ollie.
Also, it is to note that the skater is crouching down. A low center of mass will be critical to getting a high jump. During the jump, notice how his rear foot exerts a much greater force on the tail of the board than his front foot does on the nose. This causes the board to pivot counterclockwise about the rear wheel.
When the tail strikes the ground then exerts a large upward force on the tail of the board. The board will then bounce up and begin to pivot clockwise as a result of the upward force, although this time it will pivot clockwise around its center of mass.
As the board is now completely in the air, the skater will slide his front foot forward using friction between his foot and the rough surface of the board to drag the board even higher.
Furthermore, the skater will begin to push his front foot down, causing the rear wheels to raise and leveling out the board. During that, he lifts his rear leg to get it out of the way of the rising tail of the board. If the timing of this motion is perfect, his rear foot and the rear of the board rise in perfect unison, seeming as if they were stuck together.
The board is now level at its maximum height. With both feet on the board, the skater and the board will begin to fall together due to gravity. Gravity will eventually win out and the skater bends his legs to absorb the impact of landing.
Let's use some equations and apply this mathematically.
So now we are going to be solving for the maximum height. We're going to be using the equation maximum height is equal to 1/2 of times gravity times half of the time squared. So we know that gravity is equal to 9.8 meters per second squared. And then we also know that the time it took for Z to get in the air was 0.4 seconds. And then we're going to divide 0.4 seconds by 2, which is 0.2 seconds. And now we are going to plug in all of these numbers into the formula in order to solve for the maximum height. And the answer that we obtained was 0.196 meters, which is the maximum height.
Now we are going to discuss the dynamics of an ollie.
Dynamics in physics is a branch of physical science and subdivision of mechanics that is concerned with the motion of material objects in relation to the physical factors that affect them: force, mass, momentum, and energy.
Specifically, the conservation of angular momentum of the skateboard during an ollie from the moment after liftoff to the moment before landing.
This equation shows that the angular impulse is equal to the change in angular momentum. We will focus on the right side of this equation.
So, an ollie involves two separate changes of angular momentum. In the first phase, immediately after adding energy, the skateboard experiences liftoff, which creates a change in angular momentum around the back wheel of the skateboard.
As you can see, the skateboard is turning counterclockwise around the rear wheel.
As the skateboard reaches maximum height, Z moves his foot forward and creates a change in angular momentum around the front wheel of the skateboard.
Notice the angular momentum is now clockwise around the front wheel, thus reaching the second phase of an ollie.
This motion continues on to just before the skateboard lands on the ground. The angular momentum is conserved from the point to liftoff to maximum height, and also conserved from maximum height to just before landing, thus achieving a full conservation of momentum for the entire process. Throughout this project, we learned more into depth about forces and how they play a role in our everyday lives, such as skateboarding. We also learned about a new topic called dynamics and how they play into skateboarding with angular momentum and the formula used for it.
That is all the information that we have to present for you all today. So thanks for watching.